Good morning, everybody, learners of grade 8 and 9, and the colleagues. My name is Thapelo Pitso, subject advisor of grade 8 and 9 mathematics in Motao District. Today we'll be talking about straight line geometry. But the approach will be in a way assisting you in revising your equations. We'll be looking at properties of angles. We'll be looking at straight lines and parallel lines, triangles and quadrilaterals. Remember, like I always say, mathematics is a relationship subject. Now I want to see how the line relate to each other, and when they relate, what do they give? Angles, and if giving angles, what is the relationship between those angles? Right, just as a warm-up, as a reminder, let's start here. And my advice is, as a learner, you can be able to do mathematics yourself, read your textbooks, analyze, try and find out what could be the pattern. Where you're stuck, you can always ask your teacher or somebody. I just want you to observe what I'm going to do. And in observing, try and explain what I did. It will definitely improve your understanding. Right? Here is where I'm starting. Let me start here with a point, right? And after that, please observe and try and tell me what I did. Just observe what I'm doing there. 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 So, in short, you can say, I drew line or points together, or joint points. Joint points or points together. Joint points on together. Ultimately, if we do it quickly, it's still the same thing. You are joining points. Hey, yeah, this seems familiar to you. And what do you normally call this? A line. But remember, my point is, in you explaining what I did, then you will understand. It will be easy for you to be able to define something by defining what you see. And remember, in English they say it in your own words. So in my own words, I will say, I joined the line, points, combined points, combination of points, joined points. In other words, in saying that, you are defining what is a line. Joint points. In two ways, but in your own ways. Combination of points. That is what a line is all about. So always observe, when you do something, try and understand what is in front of me. When you are doing your mathematics, reading your textbook, whatever, examples, what is happening? When you look at patterns, you always, what is going on here? So that will always help you. Of course, where you see, man, you are not really making it, then you can consult. You can ask your learners in class, you can ask your teacher, and so on and so on. So that is a line. What do I mean by this when I say check what is in front of you? Let's look at this page. for example. Let's look at this page. You see, it's right in front of me and you. So what is in front of me and you is a side with, it's a figure with 4 sides. 1, 2, 3, 4. You see, it's right in front of you. And if you measure it, you'll find out these sides are equal. But again, now, you remember we spoke about the relationship. We spoke about the relationship. Once more, let's call this one side 1. Let's call this one side 2, side 3, not in a particular order, side 4. So it's something that is in front of you. What do you see? Now we see this side is facing this side. So they are opposite sides in mathematics. The side facing each other, opposite sides in mathematics. The side facing each other, opposite sides in mathematics. That's what I'm trying to say. Every time you be asked about the rectangle, it's all over. Your table, your door, your windows, wherever you're working, your cell phone, you see rectangle. But you just have to take it to mathematical language, basically. Because maths is everything. Maths is what we live. Maths is what is with us. But now we take it to that language of mathematics. So this side is opposite this side. And then when we measure this side, we find out it's equals to this side. Relationship. That's why I say relationship. The opposite sides are equal. Again, when we look at this side, measure this side, is equals to this side. In other words, it's something that is in front of you. You are explaining the relationship. You say it in your own words, and ultimately, mathematically, you say, opposite sides are equal. Opposite sides are equal of this 4-sided figure. In other words, it's in front of you. Just analyze this figure. This figure has got 4 sides. This figure's opposite sides are equal. You know, we are defining this figure now. That's what you can always do. And further, let's see what is the situation here. When we take our protractor there, we see it gives us 90 degrees. You see now, relationship, we are trying to analyze, to understand this figure. We are trying to understand this 4-sided figure. This 4-sided figure, which mathematically, like I said, remember, me and you is just taking it to mathematical language. Quadrilateral meaning 4 sides. 4-sided figure. 4-sided. So it's something that is in front of you. Even if you get a question and ever, you see it's a 4-sided figure. The relationship, the opposite sides are equal. Opposite sides are equal. We're busy trying to find out the sizes of, we are analyzing this 4-sided figure of ours. We are analyzing, what is this figure in front of us? Properties, you know, properties. So that we should know what this figure has. What are the properties? Yes, there you are. This figure has got 4 sides. Remember we spoke about relationship. Mathematics is a relationship subject. So here is a 4-sided figure. 1, 2, 3, 4 sides. And this 4-sided figure have got 4 angles as well. And these 4 angles, each is equals to 90. We've just measured me and you. So in other words, you just analyze what is in front of you and then just to take it to the mathematical world. What else can you say about this figure now? When you add all angles of this figure, how much will they give you? When you add all those angles, how much do they give you? The first angle is 90 degrees, another one 90 degrees, the third one 90 degrees, The fourth one, 90 degrees. When you add them, what do you get? When you add them, the total, adding all of them, combining all of them, will be getting how much? Yes, 360. So the relationship, mathematics is a relationship. But you can see, you look at it, what do you see here? A figure with four sides. What do you also see? A figure with four angles. What do you also see? What is the relationship of opposite angles? Which is something that you see, you just have to give it mathematically. You don't have to learn by heart because there are so many figures. So like I said, observe what I'm doing and try and define. Same thing when you're studying, when you're listening to your IBP videos, just listen. What is it saying to you? Yes, let us continue where we are, where we were now initially. You still remember, what did you say about the line? The joint points, combination of points. They say if you understand it, you can say it in your own words. We are only sure you understand it if you can say it in your own words. So you can only say it in your own words if you understand it. And you can only understand it if you observe and try and explain what you see. Let's look at the second action now. Again, now we know all those joint points. You see what I'm doing? Yes, because you'll be explaining to me what I'm doing hereafter. What did I do again? Yes, you're right. Lines meet at the point. I drew the lines to meet at the point. But remember, we said the issue here is how do you take it to mathematical language? The lines meet, we say the lines intersect. Mathematically, we say intersect. The lines intersect. The lines meet at the point. And now this point is different from our initial point. It's different. In the sense they are aligned. And what is happening, the line meeting at the point. And that point where the lines are meeting, you see, the point, the lines are meeting at the point. The lines are joining at the point. The lines are intersecting at the point. Lines intersecting at the point, and that point we call vertex. You see now? Vertex. Right. But draw and see what you have done and explain what you have done. Look what is in the book and explain what is in the book. Exactly that. And then the next element will be now, what do we say or what do we do mathematical? Remember relationships of line. Relationships of line. And this line now, the lines joining at the point, they give you what is called an angle now. An angle, that space. And even if you look at it, I say to you, how can you explain this, this space? If you know this is a vertex, if you know this is a line, if you know this is a line, then you easily say the space between the lines with the vertex. Or the space formed by the vertex. And remember again, this side as well, there's an angle again this side. So it's a relationship. You know how there's a relationship. Mathematics is a relationship. Even if you read at something that is complete, you can analyze. What is this thing made out of? Okay, this page is made out of many lines. It's made out of many lines and so on and so on. So, like I said, remember we are talking about relationships, but we want to take it to mathematics now. Again, we need to take it to mathematical language. right? We could have drawn this line to come this side, and they meet at the vertex. They meet at the vertex. Now, using our protractor, let's see our degree there is 180 degrees. 180 degrees. Your straight line gives you 180 degrees. That is your straight line. Now, again, we're talking about relationships. On top of these lines, how many angles do you have? You've got this angle. You also have that angle. Now you have to explain this angle is next to this angle. This angle is a neighbor to this angle. This angle is next to that angle. Next. But mathematically, what do you say again? Adjacent angles. Mathematically, we say neighboring angles, angles next to each other. Mathematically, we call them adjacent. It's just taking you from your understanding and taking to mathematics. Your understanding and taking it to mathematics. That's how you build the language. Even if you forget, it will come naturally. Just analyze what you see in front of you, and so on and so on. And remember, what did we say? We said this angle, the straight line angle, when we measure it, it gives you 180 degrees. Therefore, telling you angle 1 and angle 2, when you add them, angle 1 plus angle 2 should give you 180 degrees. But how do we know? When we've just seen from a straight line, what is the reason? Why are you saying angle 1 is equal to angle 2? Angle 1 plus angle 2 is 180. Straight line. We have seen the straight line, we have measured the straight line, gives us 180. Even if you go to your textbook, whatever, you look at what is here, you can still define, try and explain, I see a line and a line meeting at the point. And then that space there is called an angle. I now know to form a line, the points were joined. And I now know the angles next to each other, the neighbor angles, they are called adjacent angles. Right? Relationships, all the time look at the relationship. Properties of this figure. Your desk that you're writing, the table, your windows, you always see this kind of figure, I meant to say. And particularly because of this property, rectangle, this type of figure is called a rectangle. Rectangle. It's a four-sided figure. It's called a rectangle because of degrees of 90. Degrees of 90. Each angle is 90 degrees. So it's in a relationship. How are angles related to this figure? That's basically that. You can do it yourself. Right. Let's see from our PowerPoint. Like I was saying, we'll be looking at properties of angles, but now we reminded ourselves, what are angles now? We also reminded ourselves about straight lines, triangle, four-sided figure, and a quadrilateral, which is a four-sided figure. Can we observe this one? Relax. Remember, let's relax when you do mathematics. You know, we are always in the hurry, under pressure. You remember now, I was just talking about your rectangle. You still remember? Let's go back there. Let's go back there and see our rectangle quickly. We'll come to this figure. We'll compare it to this figure. Let's quickly. You see? Your four-sided figure, your quadrilateral. When you add all the angles, they give you 360. Right? That's what we're trying to check here. We have just seen when you add all the angles in your quadrilateral, they give you 360. But this one is not a rectangle. You know why? Because we don't know the size. We are not given the sizes. These are 90. If we knew, we were told, we were informed they are 90 degrees. So it's the same thing when you cut all those angles. You can cut all those angles like you could also cut your angles. Cutting all those angles of 90 degrees and putting them around a point, they will give you 360. Remember what we said, the quadrilateral is a four-sided figure, 1, 2, 3, 4. A quadrilateral have got 4 angles. A triangle, 3-sided figure, 1, 2, 3. A triangle has got 3 angles. So when you take all these angles and put them around a point, you remember our 490s, they will give you 360 around a point, or it's called a revolution. That's what we know. We already know. Same thing when you go to our triangle, you still remember when you add all angles of a triangle. Same approach when you cut them, all these angles, put them, they will give you a straight line. But you remember what you just said about a straight line. You remember we spoke about straight line. Just now we spoke about straight line. What did we say? Gives you 180 degrees. Angles on a straight line, when you add all of them, they will give you 180 degrees. Angles on a straight line add up to 180 degrees. Relationships of angles and lines and angles. Lines give you angles, and then what is the relationship of those angles? They give you 180. And later on, we'll also be focusing on your properties of parallel lines. We'll be looking at different kind of angles. How do they relate? Do you remember A and B? What do you call A and B? Are they neighboring angles? Yes. Are they how do you call them mathematically? Adjacent. Is A and D neighboring? Are they neighbors? Yes. What do you call neighbors in maths? Adjacent angles. And see here, they form a straight line. You know, that kind of thing. We'll look at the relationship. What about the line, the angles between these two lines which are parallel and the other side of transverse? That's what we'll be dealing with basically. But remember now, angles in the quadrilateral add up to 360. We've just seen with our rectangle. We've just spoken about your adjacent angles and the relationship of a straight line. But before we go there, let us go back a little bit here. Let's see whether you still remember what I said, but still observe again. Observe again. There's your point. A line to that point, or it can be two, or from the point, it doesn't matter. That line, you remember your dotted lines. You remember your dotted lines, we said your joint points, I meant to say, they give you a straight line, right? They give you a line, I meant to say. And again, lines intersecting at the point, they give you a vertex. Then the same thing you can draw it from the side. Same approach, we can draw it from the side. You can draw it another vertex. So you see now, it's a vertex facing a vertex. A vertex opposite. You remember what I said? I said this side is opposite this side because they are facing each other. This side is opposite this side. They are facing each other. Therefore, this angle is facing this angle. That is why they are called vertically opposite. Vertically opposite, because your vertices, this vertex is facing this. This vertex is opposite this one. Now, that's what we'll be talking about in our PowerPoint now. Let's remind each other again. Right. Or before we can even go there, let's again see something here. Let's see further the relationship. Let's check the relationship further. Let's try and measure this angle so that we can see the relationship. Okay? Let's look at the relationship here. That angle, 30 degrees when we measure it. Let's also measure this one. Remember we said we want to see the relationship here. 10, 20, 30 degrees. 30 degrees. Relationships. So if this is 30, this is 30. So what can you say? And these angles are vertically opposite angles, okay? So what can you say? What do you see? Vertically opposite angles are equal. Yes, you are right. Vertically opposite angles are equal. Now, if that's the case, what do you call this angle? This one and this one. What are the relationship? This angle and that angle. They are neighboring angles. They are adjacent angles. Are these angles forming a straight line? Yes. Okay. Are they forming a straight line? Yes. So, what is the straight line? What is the degree of a straight line? 180 degrees. 180 degrees. So, what could be this angle be? For you to get 180, what do you put here? 30 degrees plus, what do you put here to get 180 degrees? To make that statement equal, what will be your x equals to? I see for me to get 180 from 30, I must put 150 here. Meaning that my x is 150 degrees. But remember, angles on a straight line will give you 180 degrees. Again, you've got the vertically opposite angle here. You said it's 130. 150. What about this one? It should also be 150 vertically opposite angles. Vertically opposite angles. Now, try and identify here the sizes of those angles. We'll take a break while we are busy working on these questions. Find A, B, C, D, E, F. Look at vertically opposite angle. Also look at adjacent angle of a straight line. Thank you very much. While you are busy working there, I will be taking a break.